Introduce you to our programming language, introduce you the OR structures. By that I will explain what I mean by that. And then I will talk about data types, which are very important in our programming language: vectors, matrices, arrays, data frames, lists, and factors. I'll also end the session with class of apply functions. Are you hearing well, Abhi? Are you hearing well? Okay, I think both the time you said yeah, I couldn't differentiate between those. All right, so next slide is R is I will come to the installation of R Studio. Okay, R is a scripting language for statistical data analysis. It's public and free. It means you have freedom to run, adapt, distribute, and improve. You can do anything you want. You can even create a software out of that. But I don't think you can sell it. That's what it means, okay? Because they are giving it to you free. As long as you are improving it and making it for free, making it for free to others, then you are following the rules of the GNU license. It's a de facto standard among statisticians, and now it is also becoming very much followed programming language among data scientists, along with Python. Python is very popular among data scientists, commonly known as a broad term which includes computer scientists, statisticians, econometricians, psychometricians, and whatnot. Okay? Anybody who works with the numbers is called a data scientist. And it's available for Windows, Mac, Linux. You talk about any operating system in general, they know they are available. And likewise, Python is also in the same way. R is a very general purpose programming language to automate analysis and create new functions. R is a functional programming language. By that, what we mean is everything and anything in R is a function. Okay, like Python is a totally object-oriented language where everything and anything is an object. R is most of R is functional. Some of it is it follows what is called multi-programming paradigm. Okay, so it's started as functional programming paradigm, but it also follows through object-oriented structure. Okay, that's a very important distinction between this R and Python. It is easier to get help from the user community. So if you don't have, if you want somebody to help you out, you can go to GitHub or division or area in GitHub and get help. So the way to install RStudio, which is an easier version of script-based submission. When I say scripting language, what I mean is it is line-by-line code execution. You write it in a certain form following the programming construct or programming approach, because there are certain ways you have to combine the sentence, create the sentence. That script is a sentence here, okay, and submit that as a program as a way to execute in R. And a collection of sentences or collection of commands becomes a batch or group of codes. So you can submit as a batch, or you can submit as a single line command line submission with R. I'm going to show you with examples. Okay, and so that's why it's called a scripting language. You don't have to compile. It's called scripting language in comparison to compiled languages like C, C++ or compiled languages. You have to use a compiler, convert that into a machine learning. Machine readable codes, and then run it through the C or C++ engine. But R is not like that, and even Python is not like that. Python is also a scripting language. So are you with me so far? Just give me your input. Quality of call, quality of screen, and clarity in terms of my communication. Thank you. Good, excellent. So now let's see, before we install R Studio, which is the easier version, I'm going to show you what is the standard version of installation of R. So you just have to go to, since you are seeing my screen, you should be able to see this screen. Are you able to see this screen? Where I'm going to go to, this site I told you, what is that site? Is called cran.org-project.org. Okay, it's an org society because non-profit. So let me go there and download the software. So I go there and then I look for download for Linux. No. Download for Mac. No. I want download for Windows. That's what I'm going to do. Are you with me so far? You just have to keep clicking. That's all it is. Very simple. Binaries for base distribution. This is what you want. Okay. Cool. So far, I just click on this. It goes to 3.2.1. That's the latest one. It is 62 megabytes, 32-bit or 64-bit. You can select. Mine is a 64-bit computer. So I'm going to select 64-bit, but I have already done it. So I'm not going to really complete this step. I'm not going to do this. Okay. So I'm going to cancel it because I have already installed. How do I know that? I can go to because it is a touch screen. I am bringing the screen on the right side, which you saw. I look for R in the search area. Maybe this one. I don't know. It should be easier. Let's see. R 64-bit. Okay. I have installed this one. I'm going to use it. How does that sound so far? You see this one? It came back with the app. Okay. Abhinaya, are you there? Are you with me? Okay. So this is a command line, and I can submit line by line, script by script, line by line, and I will get the answer. I will get the the function executed. Okay. But you can install that in the same way too. But after you install this, you can install the R Studio. So in fact, you can click on it, click on it, it will take you there. Well, to this full screen and then click on it. It will take me to our studio. I'm going to minimize this. So it went there. Let's see. I minimize this also, but it is working on one. Our studio is here. You see this one, how I got it? That's the last one that opened, right? So I click on it and then I download here our studio. That's all to it. Our studio, select products, our studio, and then you can install this also. Download our studio. Are you with me so far? Abhi. Okay. See, you got to keep changing your yeah to everything. Sometimes, I want to know whether, see, I have to look at the time to figure out whether it's the latest one or not. So, yeah to our studio, or something like that you have to say. Okay, so it's easier for me. Are you with me? Are you able to hear me well? Are you able to see the screen? Okay, sir, good. All right, let's keep going. Excellent. So you can do that, and you can see this small video also, what they talk about R Studio. If I do that, it won't come out well in your screen, so I'm not going to do that because it's harder to play a video that catches up with you exactly the way I see. So I don't want to do that. I close this one. That because I already installed that. How do I know that? Let me go touchscreen search R Studio. It's not there. I have to install R Studio. Maybe I took it out. So let me do that. R Studio, install R Studio. Okay. Because it is a desktop only, it's not a server. I'm not interested in server, so I click desktop. But I want this one, not this one. Okay, commercial license I don't want. Okay, click on this and then I install. It is again another 73 megabytes. If I click on this, it's going to take a long time, I guess. I don't know, but it will at least interfere with the quality of the call. Okay, so don't give up your heart, and I'm going to say run. It's downloading. It says it needs 2 minutes. Are you still able to hear me well? Okay, Abhi. Excellent. Are you able to see the screen well? Is the screen clean to you? Venki says yes. Abhi says yes, clear. Excellent. Okay, let's finish this in 1 minute. It will be done, and then we will have our studio. There is an advantage there in our studio. You can see the data sets, whatever you data sets you are opening, the directories you can see. You can see the packages that are installed in the system because R has tens of thousands of packages, and the standard base package cannot cannot install all of them at the same time and make it available efficiently. So it is left to the user. Exactly, you are right, Abhi. So you have so they leave it to the user to install specific packages depending upon the situation. That's what we will also do. Otherwise, it will become too much overload on the system. Okay, it is running security scan now, and it will install automatically. And it says this RStudio hard drive change. I say yes. Next. You are seeing all these things, right? Okay, good. Excellent. And then I install RStudio. It is doing very fast. It's a very nice package, very efficient package, and it will all be done very quickly in no time. So once we do that, we will start exploring our data structures. That's our first lecture. Okay, data structures. We'll talk more about object-oriented programming language paradigm later on, when I also talk about Python. And for now, we will work with the R and learn some nice basic functionalities. It is done. So now I have R Studio. So let's see. How do I know that? One second. I got to just search, right? I'll go here. I bring search and then ask for R Studio. Cool. It's there now, isn't it? Close this. Let's see. Close these things. I don't need them. You see, there is a difference between this and this, right? You see the difference? This is just it allows me to do the script, and then outputs will come below this. Um, Sometimes the space it gives is here because when I draw the picture, when I draw the graphs, it will come out here. Okay. So that's the only. So that's all I got here in the basic installation or GUI. Okay. But here I have different spaces here. There is a command space. We will see as we submit the commands what happens to the outputs. There is a file space. There is a plots. There is a packages installed. These are all the packages that are installed. See, I cannot see these things easily in this basic or GUI. RStudio provides me that facility. And then there is a help file, and then there is also viewer. Okay, this is where the data sets are, the outputs are going to come. We'll see. Then here, I can see history of commands I have used in the past. These are all, for example, the previous commands. Even though because R is already installed, it got all these commands from that history. Are you with me so far? And then this talks about, and then I can open the file, save file, source the file. Sourcing means submit the batch file. You know what is a batch? Batch is a collection of scripts. So I can source the file, go to a specific file and source it. So if you do source the file name, it will execute that file. Are you with me so far? Some basics I have covered for now. Abhi, are you there? I need interactions all the time. When I say ask a question, please respond, because that's the only way I know you are connected live. Okay, cool. Thank you. So let's do some simple things. I said data structures is next topic that we want to go through. I said the basic thing is vector. Well, scalars are basic things. Scalars are just values of a variable. Okay, one value is scalar, like a equal to 2. Assignments, a assigned 2 is assigned to a. This is how it needs to be read. 2 is assigned to a. That is left arrow, right? Means 2 is assigned to a. Means if I recall a, it says it is 2. Okay, so this is a scalar. One value variables are called scalars. One value variables are called scalars. You with me? Next is vector. Vector is a collection of a sequence of values. It could be strings or values. Okay, for example, and it is covered as C. The function is C for that. So instead of a doing a as a scalar, let's do this. Did you hear me? What I said, Abhi? So the vectors are using the function C function. That means C means concatenate. Concatenate the items that are going to be inside. For example, I will say 4.3, comma 6.7, comma minus 66, 0, comma 8. I'm just going to do this. So B is now a vector. It has a collection sequence of items of the same type. I'm going to talk about type now also besides the vectors. Vector is a sequence of items of the same type. In this case, item refers to values of the same type. That means they're all values. Vector means more than one number, but it could be more than one string also. Okay, vector can mean more than one string also. It can be a string vector, right? For example, C to Sam, say Fred, say Ben, say Abhi. How about that? Okay. I don't know why he didn't give me double quote. I have to look into that. Oh, I don't want to use C now. I should use some. I don't want to confuse the system, right? It won't, but I want to be very explicit about it. So if I recall C1, it comes back all those sequence. I meant a very important word, sequence. Sequence means always it has an index. Okay, in a sequence, the position is important, right? So in this vector C1 or in this vector B, first element for B, first element is always 4.3. It will not change anywhere else. If you want to call the first element, if you want to call 4.3 in B, you have to say like this. Very carefully. I put a square bracket. Okay. Even though when we generated it, because functions start with parentheses, left parentheses, no, single. What is this called? This is called single parenthesis. Sometimes it's called single parenthesis. Okay, we'll call it as regular parenthesis. Parenthesis means this is what it is. Unless I say double parenthesis, this is what double parenthesis is. Okay, or no, square parenthesis, square brackets, not even parenthesis, square brackets. When I say parenthesis, this means this. Square brackets means this. So the access to a specific element is through the square bracket. Are you with me? So if you want to recall a third element, what is it in B? Third element in B, it will never change. The position is same as the value, right? The position and values are the relationship between the position and values are maintained. That's extremely important, right? So if I put B of 3, B minus 66, exactly. On the other hand, C1 of, can I call this way? What will it be? Are you there, Abhi? Yeah. So what do you think it's going to be? See, learning, one of the important characteristics of continuous learning is that you should be able to predict the next step. Small step, but does not a big step. You should be able to predict. Okay. What is C1 of 3? C1 of 3. Straightforward. Get it? But very interestingly, it still says number 1. What does that mean? See, the third, I'm calling in a third position, but it is saying the position 1 because whatever you give as output, that itself has a vector position. You know what I'm saying? Whatever the output coming out of a function, in this case, is a vector. It doesn't have to be always like that, but in this case, it's a vector. But it is only one output, so it gives 1. The whole thing is one output, so it gives one. See, the whole thing here is one output that gives us one element. Okay. Here also, it's the whole thing is only one. The output of this is only one. It is identified as this way. Now, what is the benefit of this? Because I can say C2 is assigned as C1 of 3. If I do that, C2 is, what is its length? C2 length is what? Predict. C2 length is what? Length means number of items, right? Okay. When says one, Venki says one. What is it, Abhi? In fact, there, no idea. Okay, I couldn't see that. Let's try. The good thing about programming is that you can always test the ideas. Okay, so it stored the value of C3 into C2. Okay, now just let's try whether I can use the word, I can use the function length C2, right? When says it is 1. Indeed, it is 1, right? See, if I put this way, also, even though there are multiple elements is there, let's see what it should be, right? I'm going to go for this one. C1, C1, 1. I'm going to copy this, and one nice thing about this R is that you can recall the history by top arrow. Do you know what I'm saying? See, there are 4 arrows, right? At the right bottom, there are 4 arrows. So if you keep pressing the upper arrow, you get the previous. Sir, what is C2? C2 is it's a right now it's a vector. C2 is a vector. Let's just do this. C2 is a vector which has, why is that value comes 6? C3, C, what is C first of all? Where is C? A is this, B, C1 is this, C1 is this, B, C1, C2. C2, oh, C2, C3, C of whatever the C value, C there, let me just see what is C. Okay, 146, you know where it's coming? Can somebody guess that? Even though I didn't put it here? Yes, exactly. I stored this workspace previously that is coming out here as a C value. So what are the things that previously stored? You can go back and check. Okay. I'm going to see. I thought I cleared it, but I cleared the commands, but not the workspace. At one point, I stored the workspace, and that it is coming from there. So now I want to know what are the things in the workspace. One command to use. Please note this command: list command. Okay. When you put the left parenthesis, right parenthesis, you are calling that function. Okay. So you are applying that function with a default value. So all these values are coming from the previous history. You see, that's why I got C. C is here. Are you with me so far? Abhi, I think it's a little bit of a jump I made here. Are you with me so far? Cool, very good. Venki, good, excellent. So I didn't realize that. So when you asked me that question, I was wondering where is it coming from? And then I remembered that, you know, from the workspace that I saved from the previous run. And I have not just that alone. For example, X is also there. So let's see what is X is. Okay, from the workspace, it is coming from the workspace. Some number sequence of 1 to 20 I stored there. I don't know why, but maybe I would have just run something, shown it as an example to somebody like you. And there is also cumulative frequency, A, B, breaks, duration, all these things are coming. Name, school, all those things. Let's see what is school is. Some these are called factor variables, you know, some classification. I'll come back to this later. Levels are A, B, C, D, E, F, G, H. There are 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 54 values are 54 values are there in this vector. I can even see more in detail like this. How? I can actually edit and check it out. There was an error there. No, don't worry about that error. Okay, I can edit and see. That is one way to see actual object, actual data. You see this one? So it is some kind of a structure. The structure is this. It's a class, and the structure is factor. The class is factor, and it is labeled A, B, C, E, D, E, F, G, H, and then it is coded as whenever it is 1, it is A. There is an internal coding there. That's what it means. Okay. There are 8 factors. Are you with me so far? I'm kind of quickly jumping on some of these issues. We'll come back and review more of this, but I gave you this command edit. Through edit, I can see actually what is there. Are you with me so far, Venki? All right, now, so I try to explain what is C. Let's go back to C. There was already C was existing there in the workspace. So when I called length, you asked me some question. Let me go back to your history. Your C, sir, what is C2 in DAT? Okay, so I'm going to explain that. C2 refers to the, I don't know. I didn't realize that C is something I only defined previously. Somehow I was thinking I defined it here. So I took the third element of C, but it so happened that third element of C is 6, and that is stored in C2. Are you with me now? That is what when I recalled C2, it printed value 6. Is it okay? All right. Now, um, now what is that? Okay. So I was saying. We talked about so far what is that, the vectors, and then how to access the vector, what happens to the outputs when we assign or when we call functions and so on, right? See, this ls output also I can store it in something, in some form, right? I'm going to do that now. Let's say ls out, okay, ls out. I'm going to assign it from ls function. Now it is stored there. Now if I call ls out, what do you think? What do you think? LS out is a complex structure. Am I right? It's not simple sequence of numbers or sequence of characters. Am I right? They are all some output members. It's a very complex item. Do you agree with me? LS out is a very complex item. Just take that word, very complex item. Do you agree with me? Said, I want an answer from both of you. Okay. Abhinaya said yes. Venki, do you agree with me? It's a very complex item. Why do I say complex item? It's because it's not just a simple sequence of number. It has a lot of complex things are there. What are the complex things? Let's see that. I don't understand. I'm coming. Do you understand, Venki, that it is the output of the ls function, ls function with a default value, right? And that output you saw here, this one. These are actually the outputs. But if you look at each one of them is different. Each one is a different kind of things. For example, A is a very simple. A is a very, first let's see what is ls out has. Okay, it will have exactly same thing what you saw before. It's not going to have anything new. Okay, but what I'm saying is now if you look at A, I want to see ls out $a, ls out 1 is going to be ls out 1. Okay, but what is A? We want to find out what is A, right? Of course, because it is there in the workspace, I can call it in a simple way like that. It's a scalar. But what is breaks then? It's because it is there in the workspace, I can call it simply like this. What does breaks mean? It means these values. What does the school means? School means more complex data structure. This is a factor data. I'm going to talk to you more about it, which has levels A, B, C, D, E, F repeated 54 times, something like that, 42, 43, 44, 45, right? There are 54 records. There are 54 items. Okay, first 8 of them are A, next are 6 of them are B, like that. Right? Are you with me so far? So is containing list of data. Exactly. It contains, I would say, list of data items. Data, instead of saying data, let data items, because each one can be different. Okay. No, I'm not going to go too much detail here, but I'm just telling you that ls out is a very complex structure. We are going to call that as a list. Later on you will see what is the importance of list, and you can see that we need a container. Ls out is a container that contains all kinds of complex lists, complex data items. Okay, so that such an item data type is called list. Now let's go back to the vector. Now I want to talk to you about matrices. Yes, you are right. No, no. Can you explain what you're saying? You are saying ls of some specific item. You mean like this? You mean a like this? It won't. Okay. The only way to do that is you have to call the members, because you know these numbers. So if you say ls, you know the list, right? All the items in the workspace. If you do this, you know all the items. You just have to call, select that you want, and then just type it. L1 is 17th item. L1 is 17th item. See, it is a true or false statement, and A has the value true, B has the value false, like that. It's very easy to check it out, what it contains. That's all I'm saying. You don't have to say ls within parentheses, all those things. Are you with me, Abhinaya? Okay, good. So if I want to check what is this school frequency is, just for the fun of it, right? Yes, these are the frequencies. A has 10 values, B has 6 values, C has six values. Because it's a frequency, I know. It's a frequent, the time, number of times. That's what frequency means. Okay. All right. So we saw scalar, we saw vector, we want to see matrices. So I'm going to go to my notes to do these things a little bit more systematically, so that we can cover this quickly. We can cover this because if I see the notes, it's easier. Or programming summary. I want to go that. Okay. This is something I distributed to students, and I mentioned that no, there are options you can set aside. Okay, you can read that. It's not difficult. So let me walk through this document. With all those concepts. So we can use a generator called sequence. We can use a generator called sequence to generate sequence of items. Are you with me so far? Abhinay, I keep asking those questions because I need to be sure that you are connected always. Sometimes people might drop because they don't mean to, but they may end up dropping, and I will think that they are hearing me, but they may not. Here while I continue to explain all these things. So now let's do this. Okay. What I have to do is I have to do, okay, so that I can see this document also side by side. Because it is not showing me all the line items here, I'm going to put this here and then come back here, copy and paste it so that I don't have to type it and keep moving. Are you with me? All right. So I do this. This it's in some sense it is in some sense predictable, right? What I'm saying is this is a function first of all, because it has left parenthesis, right parenthesis, right? It's a function, and what I'm saying, generate the sequence of values between 0 and 1, but I want a length 11. So obviously it is going to divide it into 0.1, 0.1, 0.1, because it's 0. It starts with 0. It is going to be 11 values. Are you with me? This is a function, a simple function, which has these three values. There is also another value, another parameter called by. Okay, you can jump values also. This is to define the length. By defining the length, you are creating the sequences, but there is also by. So if I want to know more about sequence, what do I do? Just put question mark sequence. What happens? See, it is giving me help this side. This is where the help is coming. Sequence is a function. From to, you can put from to is what? 0 to 1. By also you can put, right? By increment of the sequence. So if I put like this, let's say, same command, how can I recall that command? Press upper arrow. But instead of putting length out, I'm going to put by equal to, let's say, 2. What do you think is going to happen? What do you think is going to happen? Just predict. Prediction is part of learning. Remember that. What happen? I want to see your answers. Can't hear me? 0 to 1 only? No. Let's see what it is. Abhinay, can you hear me now? Is it better? Hello. Okay. Can you guess what it is? Venki says that there are two values, that is 0, 0.0 and 1 if I put by. Just try. Just let's put a stake on the ground in prediction so that even if you fail in the prediction, you can learn, right? All right. I'm going to say enter now. It says 0 value only, because what we are saying is that no, it has to generate between 0 and 1, but it has to jump by 2. But if it jumps by 2, it goes to 2, 0 and 2. So 2 is not available, so it will only include 0. Does that make sense? You are very close, Venki. Okay. So if I put like this, what happens? If I put like this, what happens? What would happen? All. There's a word for that. If I put this, what will happen? Go, go, go. Just predict. Say something. Venki says it's 0, 2, 4, 6, 8, 10. What about you? Try a guess. Okay, it is 0. What we are saying is that you include 0 and include 10. These are the endpoints. Okay, include 0 and include 10, but it should be jumping by 2 points, two integers. So it is 0, 2, 4, 6, 8, 10. Is that okay? Yes. Is that okay? Yes or no? You got to quick. You cannot hear me. I'm sorry. Can you hear it? Can you hear me better now? I don't know what is going on. Are you able to hear me? Venki, are you able to? Okay. All right. Hang in there. So let me. I'm going to give you more interesting. Quickly, let's go through some of this. I'm going to do this. Oh, if I do this, what do you think will happen? Oh, what I said is, in the previous command, it is always first number is from, next number is end, from 2, but include the endpoints. But then what you have to do is you have to jump by two integers. Here it is integers. If I put 2.5, what will happen? Can we just check it out? Okay. You have to guess, Abhinaya. That's the only way to learn. Guess. It's okay to fail, but you have to guess. Okay. Okay, let's see. I think you are very close. Abhi, you want to predict what is likely to happen? This is just a way of learning, little by little. There is a long way to go, but I'm just telling. Okay, let's try. So it is 0 included, 2.55, 7.5, 10. Does that make sense, Abhinaya? Are you there? So if I do this, what will happen? do this, what will happen? There's a lot of number that's going to come out because the jumping length is small, right? All these numbers are so there's it's quickly comes out all these values, right? I want to introduce you a function called which. It's a very useful function, okay? Which refers to the index, the position. See, sometimes we want not just the value of the position, but we want a value or a string of the position, but we want the position. Does it make sense? But in a simple example, I'm going to explain that to you. Want to know the position, the index of the letter R in the object called letters. That is it's an internal function that is given to us. Are you with me? Say yes or no. Okay, good. So what do you expect this one? I said it gives you, which gives you the index position. So what is the index position of R in English letters? A is 1, B is 2. What is R? That's what we are going to do. You don't have to count. Helps you. It is the 18th position, 18th index. Are you with me? And let's see. So what happens is that it is actually a truth function. What is called R in alphabets? Yes, it's called a truth function. Okay, because actually internally it really creates a truth function. What we are saying is that the truth function says when letters is equal to R, yes or no, yes, right? At that time, what happens? Let's do this one. You have to do what is meant by L1. Okay, so I am defining L1. This is L. Okay, first one is L. Letters. I think LL maybe L. Okay. So I am storing the truth function, truth vector, true, false, true, not available. It also includes not available. Not available is a missing representation in R. NA is a missing representation in R. And then fifth value is false, sixth value is false, seventh value is true. I am storing this in L1. And then I am asking which. So it is always giving you the truth position. In fact, that's what I should have said here. It's not just the index. It works out as index exactly in this case, but a better way of saying it is the truth position. So for second position is false, so it's not giving you that information. Third position is true, so it is giving you the third index. Fourth position is not available. That's not a true, right? It doesn't have the truth binary value. Position is false. We don't want that. The function should not pick up this one. Function should not pick up. That's what happens. 137. Are you with me? No. The letters has, for example, if I call in letters, it will tell you all the 26 letters. That's all, right? So when I say which letters is equal to R, the truth position, where does the truth position happens? In the 18th position. That's what it all says, this function. Now is it clear better? Which function is looking for the truth position? That's a better way of saying it. Not just the position of R. It is true, position of R, but that's where it will become truth. Okay. When so now let's do a little bit about truth functions. Okay. Um, so I want to find out there is another function called %%, which is what is called the modulo function. That means modulo function refers to the remainder after the division. What we are saying is, no, you take the vector. So let's do this one. If I do it this way, it is much easier. I want to just play with the truth function a little bit more. Okay. So if I do this alone, what do you think you will get? Do this alone, what do you think we will get? Yeah, finding the position of the which refers to finding the truth position. Let's put it that way. Finding the quote truth, quote unquote position. Venkat. So if I put 1 colon 12, what do you think will happen? It should just give 1 to 12, right? It gives you 1 to 12, right? Are you with me? Sequence of 1 to 12. That's good. Are you there? Okay. But if I say I do that, but then I don't want that. I want modulo 2. What does that mean? That means you take that sequence, divide by 2, and show me the remainder. That's what this function is. Do you agree with me? Take that sequence, I divide it by 2. And whatever is the remainder is what is giving me percent percent. Percent percent is a very special function. Yeah, 2 times. What is that? 2 times. No, it is going to give me whatever is if I divide 1 by 2, what is the remainder? 1. Do you agree? If I divide 2 by 2, it is remainder is 0. If I divide 3, see it is taking each one. That's what this means. Each number in the 1 to 12, you take each number and divide it by 2, but don't give me the quotient, but give me the remainder. Okay. So it should be only 0 or 1. Do you agree? First of all, it should be only 0 or 1. Do you agree? It cannot be anything else because it's all only remainder we are talking about. Or why percent percent? It's a function. Just take it like division is a function. Like division is a function. Percent percent is a particular type of function, which is modulo function. No percent. No, the percent is a different type of function, but this one is percent percent. You'll see what it is if at all. Okay. Now, do you agree the remainder should be 1 and 0 only? That's what it is, right? That came out to be like that. So interestingly, if I want to find out even number anywhere, I just have to say modulo equal to 0. Do you agree? So if this is equal to 0, okay, equal to 0, I put double equal. That means exactly equal. It is going to give me those positions where the remainder is 0. That is second position, fourth position, sixth position, and so on. Do you agree? Those are the position will become true. Again, see, when we put this one equal to, we are checking the validity. That means either true or false. Double equal means you are checking the validity. Exactly equal to 0 or not. That is means it's a true or false. So you have to check out, sometimes you are creating truth functions, sometimes you are creating value functions, sometimes you are creating vector functions, sometimes you are creating matrices. We are coming there. We'll come. Okay. Are you with me so far? Check. Yes. Cool. Now, this is the way to find out your truth. Where is the even number occurs in a sequence, where is the even number occurs and where the odd numbers occurs. This is a way to check it out. That's a quick interesting way, a simple interesting mathematical way of applying more and more complex functions. Now I want to define a matrix. Okay, so this is the way to define matrix, because we have seen so far vectors. I'm going to define a matrix, which we saw already. This is the way to define. I can assign some numbers, take a vector of numbers, and give number of rows and number of columns. How do I know that that is true? Just check it out. See, 3 rows and 4 columns. Are you with me? So instead of putting 1 is to 12, 1 to 12, I can put any number of vector values, right? I can put any number of vector values, right? But I made it very simple using 1 to 12 because it's easier for me to do. I could have done this way also. M1 and M1 with M1 as a matrix type of data, and I'm going to put these values. 8, 5, 2.1. I want to create 12 values to do similar matrix, right? You know what the easiest way to do? I will create the vector first and then I will call in that vector. How about that? Am I making sense? Create the first the vector values. C 3.3, 2.9 minus 5.1, 0 minus 5.7, 66 minus 9, 1.5, 2.2, 4.3, 5.8. How many values I have already? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't want more than 12, okay? If I have more than 12, I have to do 4, 12, 13, 14, 15. Let's put 15 just for the fun of it, okay? Is it better voice now, Venki? Is it better now? Abhi, are you there? So I created this C1. What is the length of C1? There is a function called length, right? I can check it out. It's only 14. I want to put more values. So what am I going to do? I want 15 values, I said, right? But I didn't make 15 values. So I'm going to make one more change to that. I'm going to say C1 comma minus 100. How about that? Do you think it is correct? Sounds correct, right? Yes or no? Yes. Let's see. Yes, it did take it. If you look at C, it took 100 also. If I put length of C1, it is 15 now. Now I can use that to create that matrix that I was telling you. I don't have to generate the numbers. I can bring in any vector of values. That's all my point is. What did you say? I don't know. Oh, you weren't able to. You weren't thinking that it will be correct. Is that what you meant? Okay, so no problem. So let's do this matrix. I'm going to call in C1 and then I want 3 comma 5. I could have done 5 comma 3. Why not? Let's play with this way. More rows than less columns. Okay. See whether it will work. How do I know what the structure is? Bingo. Got 5 rows and 3 columns. Do you see what I have done so far? Yes. Okay. Now, I can do operations. We can always call function of a function of a function of a function. That's the beauty of functions. As long as they are well defined, you can call in function of a function. So what I'm going to do is I'm going to do which function I'm going to apply m1 modulo oh, yes, everything. Okay, let's do that. Modulo 2. Okay. There's going to be only one value that will work, right? Modulo 2 will become 0, only one. That is 1.1. 1, am I right? 1, 1. This is the only one that's going to become modulo 2 equal to 0. Why? Oh, okay, okay. Thank you for that question. So what Venki is asking is, Abhi, I think he's saying what because the matrix can be arranged in any way, right? But always column is major. First, you are finishing the first column, and then you are coming to the next column, and then you are coming to the next one. That's how it is done. It is not done this way. That is the default. You can change that. Default is always column. It's called column major. Answer your question, Venki. And do you understand what I'm saying, Abhi? It's always see took the 3.3 and put it below, right? And then 2.9. Third value is 2.9. It's going down, and then after the fifth value is done, 0 is coming to the next column. So column wise is default. Column wise. Okay, we can change that by giving you some change command here in the when you define the matrix, you can change it. Now, I want to do m1 modulo 2. What do you think it will happen? Equal to 0. That means I want even numbers. What do you think is likely to happen? Guess. Quick, quick, quick. m1 modulo 2 equal to 0. True or false? So it's going to create a matrix of true or false, right? Agree? And where will it be the true value? place it will be true value. Actually, I'm coming. So, Abhi, do you understand that there is an M that we created, M1, we created as a matrix, and we checked out that matrix is this, right? What I'm saying is, I take the M1 and then find out modulo 2 equal to 0, right? I'm operating on the M1 matrix with the modulo function 2, and I'm checking the truth or true or false situation where does it where the modulo will be equal to 0. Do you agree with me so far? Okay, good. So my question is non-zero true parallel. What do you mean? Appear for non-zero. The true will appear for the zero remainder. That's what the even numbers are, right? We talked about it. Are you clear now? Okay. Are you clear, Abhi? Looking for the truth position. Where is the true position in a new matrix that is going to be created by this modulo 2 function applied to M1? And it is a truth binary function because it's equal to 0. Exact value 0. It should be there. You see this? Does that make sense? I didn't think about this 0, right? That's also true. True is happening in 1 comma 1, that is first row first column. True is happening in 1 comma 2, that is first row second column. It's happening in 3 comma 2, that is third row and second column. It's happening in fifth row third column. Are you with me? Do you understand? Quick answers, please. Always. Abhi? All right. So, do you understand now what is meant by truth function? What is meant by matrices? What is meant by vector? What is meant by scalar? How do we generate values using sequence function? Hmm? Is it happening because all numbers with 0? All numbers, no, with the mod, this is what the, okay, this, first of all, this one is just a modular value. If I don't put this equal to 0, I'm going to get only the 0 or not 0, the 0 or the other reminders. Let's see what those are, right? Out, and then we'll go from there. So first one is 0, but next one is remainder is 1.3. Do you agree? Venki, do you agree? Abhi? Modulo, this is double percent is a what is called modulo function. It's a function. Modulo function. What it does is it divides the number and gives you the remainder. That's the function. That's the purpose of that function. For example, clock, right? What is the modulo? That is number of hours in a day. Number of hours in a day. Modulo 12. Do you agree? If it is not a military time is, they say military time is 24 hours. There is no modulo 12 there. Modulo 12 doesn't. That is only, you'll have, 1 to 2. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 10, 11, 12. And then 1, 2, 3, 4. You agree? It's not modulo 2. Clock is modulo 12. Now tell me what is a week? If it, what is a week? If I take a month and what is the modulo number for week? In a calendar, you take the calendar month and then you start with it's not modulo 2. Don't go to modulo 2. It's not modulo 2. Clock is also not modulo 2. It's modulo 12. Week is modulo 7. It's not 2. 2 is for even number and odd numbers, or even numbers, you get it? So the modulos are very useful functions in many places. Just I introduced that, to talk about function, some various attributes of data types. So we get these modulos. So modulo 2 is, it is helping me identify which are the even numbers in this matrix. So instead of saying m1 person 2, I can do m1 person 2 equal to 0. That's finding the truth function for the even values. That's what this is. Okay, now it is clear. Good, 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 very good, very good. All right, now go to, okay, I want to talk to you about how to identify members in a vector. You know that by sequence, right? You know how to identify members in a vector. For example, if I put C1, very easy to identify members in a vector. You identify by the index position, right? If you want to identify members in a vector, index position, if I ask for C1 3, what will happen? That's a way of identifying third value in the vector, 2.9. But if I put C1 greater than, let's say C1 greater than 0, what do you think it is going to come? Remember, okay, that's fine, when you can go, you can leave. Okay, thanks for joining me, because Venkatesh is our person. So if I put C1 greater than 0, what do you think is going to happen, Abhinay? It's going to create a truth function. Do you agree? Wherever it is greater than 0, it's going to say true. Wherever it is less than 0 or equal to 0, it's going to say false. Do you agree? Yeah, cool. Let's see that. You are indeed true. Okay. See, for comparative operations, comparison greater than 0, less than 0, and so on, so it's a truth function, really. Okay. That's another important point. But we talked about how to access specific members. But that is for vector. But if I want to access matrix, then I have to give two numbers, like M1. If I give, no, the output is the binary values, like the true or false function output. Okay, right. It's not a number. It's true or false. Now, if that is to access the, in the case of vector, I have to access. I can access members by one number, right? C1 of 3 gave me the third position. But in matrix, I have to access it by two numbers, because there is a row and a column number, right? So if I put, there is no, in this one, I did not do anything, modulo function. I just asked greater than, which one of them are greater than 0. That's all I asked. Are you with me? In this case, there is no modulo function. It's not true. Always only modulo function creates it. Okay. All right. Now what I'm asking is, we accessed members of vector by one number. How many numbers we need to access the members of a matrix? Just guess. Quick. We needed one number to access members of a vector. Okay. Can you hear me now? Okay. We need one number to access a member of a vector. How many numbers we need to access a member in a matrix? How many numbers? You need two numbers, right? The row position and column position. Are you with me? Row position, column position. You need. Okay. Are you with me? So, voice breaking. Sorry about that. I don't know why it is. So my question to you is, M1, let's say 3 comma 2, what value I will get? Let's say 3 comma 3, what value I will get? I'm accessing third row and third column position in M1. The M1 is here. You remember M1 is here, right? I want third row, third column value. What do you think I will get? Hello? Are you there? Can you hear me? No, no, no. You are saying this value you are saying? I'm not asking for the condition here, this kind of condition. I'm only asking what is this position only, not the truth value here. There is no truth value here. Position only. So you should be looking for, do you think this is true? Do you think it is true? The value is 5.8? No, that is 3.1. 2.1 is 3.1. I want 3 comma 3. Okay. So this is one additional comment I want to make. Comments are made with this hash symbol. Hash symbol means comment. So this is not going to be processed. After the hash symbol, whatever comes until the end of the sentence is comment. So it came out with 5.8, right? So that is the way to access a member of a matrix. So we talked about vector, we talked about scalar vector matrix. What else we want to cover? Vector matrices. We talked about also give names to the rows and names to the columns. So this is a way to do. Okay, called or no, the call. Oh, one more example of M1. So I'm going to do this M1. Okay, you do. Ask me one more example. Oh, one more example here. Okay, okay. So what do you think is this one? 5, 2. Oh, not here. Yeah, I typed somewhere else. Sorry. One moment, please. Okay. Here, what do you think is 5.2? What do you think is 5.2? Hello? Can you hear me? That is correct. Excellent. That's it. Right? So that's a way to access matrix member. That's all my point is. All right. Now I want to give you. So here is, look here. If I put not one element, if what do you think is going to happen? Just guess this one. You have to guess this correctly. What do you think is going to happen? I don't give any specific row number, but only I give you column number. What do you think it will happen? What do you think will happen in the output? If I enter, what will happen? 0, 0. No, that is 1, 2, right? 0, 0, 0.0 is 1, 2. 0, 0 is 1.2. Agree or not? But I did not give any position. I didn't put, if I put 1, 2, yes, that is 0, 0, 0.0. But I didn't put anything for the first position. What do you think is likely to happen? Okay, I'll give you the answer. See whether it makes sense. It will print all the first column. Agree? It will print all the first column. Okay. See, that's what happened. Even though it is first column, it printed it as a row, right? Because it is storing as a vector. It doesn't care. You ask the output, it store it. It created the output as a vector. That's it. It doesn't know whether it is a first column or second column, third column. That you will know only by going back to the command line. That is this line. That you will know only by going back to the command line. Understand now? So what do you think this is going to happen? Yes. M1 square bracket 3 comma. I didn't put anything for the column. What do you think is going to happen? No column member is mentioned. What is it? What do you, it is not 3 comma 1. It's not 3 comma 2. It's not 3 comma 3. But it is 3 comma. What do you think is going to happen? The output. Quick. Don't worry about the values, complete values. You said 2.2, 4.3. M1 is here. I said 3 comma. What did I say? 3 comma. I didn't put the column. It's going to put all these things. Do you agree? All these three values 2.9, 66.0, 5.8. Agree? Okay. Let's check it out. That's the beauty of programming language. Indeed, it is correct. So I want you to go through this document that I have here. All right. I'm going to give you this document. It's a draft document. And array is a matrix of matrices. I'll come. One more question. If I put this one, what do you think is going to happen? If I don't put any number, what do you think is going to happen? Don't write every number, just say in words. Is it going to be a vector? Entire thing. Exactly. Entire thing is going to become as a vector. But it didn't because it is the matrix structure is kept. Still the matrix structure is kept. And if you're going to ask everything, it's going to give me the whole thing as a matrix. Agree? Whole thing as a matrix. Let's try to. So let's say, what does it say? M1. Not a type. We want to see what is the, okay, edit M1. Let's say M1. It should say the type is matrix, right? Just created this, edit. See, this is another way of seeing it. Column 1, column 2, column 3, row 1, row 2, row 3. Okay. This is another way of saying it. Last time, oh, I didn't put view. Let's say view M1 versus edit M1. In edit M1, you can actually change the values with an editor, right? You saw that earlier. The view should be uppercase. V should be uppercase. Then you have like this. But you can't really edit. Even though you can kind of select, you can't edit it. If you want to edit it, you need to edit. So far, so good. So I can change it here. Let's say I change 588, 5088. Now I save it. Close. Let's say whatever. See, it changed already. 5088. What is that? We can only view. No, you can view and edit. But if you edit, you have to store it. If you edit, let's say M3, edit M1. Okay. Now I edit 5088. So it doesn't change the M1. It just changes whatever the edits I make. File close. So now I have M3. M3 is changed, but M1 is still same. Do you agree? That is the property. That's all. Now, no, arrays are matrices of matrix of matrices. Matrix of matrices. So, for example, let's consider this. Arrays are matrices of matrices. Okay, my array 24 numbers are taken, and each numbers are arranged into dimensional 3 comma 2, 3 rows 4 3 rows 4 columns, and 2 times repeated. That's what it means. Rows. So it's going to come out output like this. For the first time, you get the iteration 1 to 12. That's what is happening. Second time, the second matrix is going to be 13 to 24. Do you understand what I'm saying? Complication is there, but no complication at all. You are creating matrix of matrices. Matrix of matrices. So if I type my dot array, it's going to print 2 matrices. See that? And here is a one interesting question. What do you think is going to come out? This number. Give me this number. My array. Okay. Give me this number, please. 2, 3, 2. What do you think this number is? 2, 3, 2. It should be second matrix, and within that second matrix, second row and third column. Do you agree? Yes or no? Hello? Can't get it. So we know how to access matrix. We know how to access vectors, right? Say yes or no. Now I'm going to give you an idea how to access array members. A? What do you mean by A? You said A. Oh, I guess you meant yes. Okay. All right. So, yes, please. Cannot hear me. Okay. I don't know. Sometimes it is doing this. I don't know when we have 15, 20 very people, what will happen to the voice? I don't. Hope that there won't be any problem. But anyway, I'm saying earlier you learned how to access a specific member in a vector or a matrix. Earlier, yes. Now I'm going to give you a way to access, teach you how to access a specific member array, because an array is a matrix of matrices. See, first matrix is accessed by putting comma comma 1. Second matrix is accessed by putting comma comma 2. If I want 2 comma 3 comma 2, it should come from this matrix. Okay. But then second row, third column. This is the second row, third column. So it should be 20. Do you agree? Okay. So let's just check it out. You see that 20? We are good. So that is how the arrays are structured. Okay. I'm going to teach you one more thing called data frames. And then we will talk about lists and finally factors. That's the end of today's lecture. Okay. Like first means two matrix. I don't understand. In what order you see 2, 3, 2? So the last one is the array number, the matrix number. I'm sorry, not array number. The last one is matrix number. The first one is matrix. 2 means second row, third column, second array, second matrix. Second row, first member is row, second member is column, third member is the matrix. Are you with me? Okay. Now, I want to tell you about something about data frame, because data frames are fundamental in data analysis. Data frame looks like a matrix, but it has mixed data. Some could be string data, some could be number data. Agree? No, understand? So, for example, if I write, so here is the vector vector D, and which is all numbers. Vector E is defined as, red, white, red, not available. Then vector F is defined as truth function. Are you with me so far? There are three different vectors, but I can combine these vectors into a matrix called a data frame, because matrix have to have the same data type, either string, character, or numbers, but not data frame. Matrix should have the same, but not data frame, because in real life, data analysis involves mixed type, indicator variable, character variables, and then numericals, right? So we need a way to represent that in R, and that is called data frame. So I can create what is called my data, call it as data frame. You have to say that word, data frame. See, I have to put D, comma E, comma F. So now it becomes a data frame, because it cannot be a matrix, because it has a mixed data, right? Data cannot be called, combining into a matrix cannot be called as a matrix, because the data cannot be mixed in matrix. So there is a new concept called data frame that is used in or to define matrix type structure, but mixed data types. So let's do this. Object my data is not found. You know why? What is the mistake here? Because I didn't put the dash here. Now let's go my data and see what it is. You see this one? See this? So it is three columns vector. Three columns matrix. D, first column is D, second column is E, third column is F. All these things are combined into a matrix type, mixed data, and that's why it is called data frame. It's a special name. special data type in R called data frame. So I can, so the question comes now, how do I access it? Looks like matrix. How do I access it? It's a separate way you have to use. You have to use dollar symbol, my data, dollar E. What do you think is going to come? All the E column values will come. Do you agree? Yeah, you are right. That one, all the E column values came. Again, it came out as a vector. Don't worry about it. That's how it will be, right? Because level, but the interesting thing is that because it is a character variable, it always considers it, takes it immediately as a levels factor variable. That's called factor variable. Automatically it builds it as a factor variable. The factor variable. Levels are coming in here. If it's F, yes, yes. Well, let's check it out, right? See this? That's the beauty of programming. It's very easy. You can check it out whether you are you are right or not. Very simple, right? Hmm, okay, thank you. Super. Uh, okay. I can assign names. See, DEF is not good, right? So I'm going to assign names to it. The way to assign is this way. See, my data has, now if I call my data, it's not going to come out with the DEF column names. See, it is coming out with ID, color, past, true or false. Cool, isn't it nice? It has more nicer way of accessing it. Good. That's it. And then list, we already know what lists are. Lists are a collection of all types of items. That's what list, we saw that. The directory is a list, right? So here is a list I can, for example, it can have a string, it can have a numerical vector, matrix, scalar, everything. It's a container. List is just a container. Does it make sense? So let's define one more list. Okay. What is W? So you see this one, W. First one is called name, second one is called my numbers, third one is called my matrix. Okay, just hang it there. Step put, just it will come. Last one is age. All different types of numbers. The matrix is, it has a matrix, it has a vector, scalar, it has a name, string, it has a number. Now, are you able to see the screen? Okay. So matrix is, the list is a container collect, having all kinds of data. Okay. So I said list is a, now I'm going to write it like this. List is a container having all kinds of data types. All kinds of data types. Remember that. Does that make sense now? Okay. Very good. You are super cool. So I told you that I wish Venki is also here. No, he was also coming along every sentence. Yes, 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 yes. Now I said we want to understand what is meant by factor. You already know this. You see, this is a factor. You saw that, right? You see, anything that comes out, E is a factor, right? Because it is tells you how many levels are there and so on. Even F is a factor. F can be a factor. Let me see. I got to check that. F is not considered as a factor. Okay? Only E because it's a truth function. Um, so when I put what is F, it just gave me the true or false only. But when I put E, what is E? It gave me the different factor types: red, white, red, and really, what is the how many different levels are there? Only red and white. Are you with me so far? E is a factor. Yes, E is a factor. So that's another type of variable. So you got so far. What are the variable? What are the variable types you got? You got scalar, vector. What's red and following? Oh, you mean this one? You are talking about this? Red, white, red, not, oh, not available. Is that what you're asking about? That means it's missing. Okay. No, what is it? What's the question? Is a variable, yes, it's a variable, but that variable is a factor variable. That is called factor. Whenever you have a discrete nominal values like this, it's called factor variable. But even though it repeats red, white, red, what are the different distinct factor values? Only red and white. Okay, are you with me? Hello, hello. Factor E contained red, white, valued. Not, you don't say valued. Levels. It's called levels, not valued. Okay. And so what are the things we covered so far? Scalar, vector, matrices, list, factor, arrays. These are all the different variable types in R. So I want to stop here. How does that sound? And I will give you this document. I'll post this video. You can watch again. Read this document, watch this video. You'll be good. I'm going to. Thank you. Any questions I may answer? Any questions I can answer for you? I have to stop this, then only to create the video. Okay. MP4. No, sir. I just need that. Okay. Sounds very good, Abhinaya. Wonderful. Keep up your good cheer. Keep up your good learning attitude. Okay. I want a lot of people to join this. I think it's a lot of fun. If you know, because this is not only you are interacting a lot more frequently, but also it gets recorded, so you can see that, where you are taking time and why and so on. You can visit and so on. Yeah, no, you'll get used to it. This is very important. The video lectures are very important. What is this? Unso NYC? What does that mean? Unso NYC. New for me, Unso NYC. Oh, yeah. Okay, sure. So, shall we stop here? Okay. Thank you, Abhinay. Have a good afternoon. Eat well. Thank you. Bye. I'm going to close and then post you the. I'm going to post you the video. Okay, I'll send you the video. I'll send it to all the class, the material, the students. Okay. Okay, sure. I'll send it to the whole class. Thank you. Bye. 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 Now I need to save it. End the meeting. Exit end meeting.